Lesson 3, Dividing Whole Numbers. We are going to start by identifying symbols or phrases that indicate that we will be using division. So we have the word split. If something is being split among different pieces, that means we are dividing. If we have 460 divided by 12, we know that that is division because it has the division symbol. 582 over 16, that is a fraction, and fractions are simply division. If something is a product, that is not division because that is multiplication. Altogether, again, would not be division because you'd be adding. 1 2/3, that is a mixed number. We are not dividing. If we are finding the quotient of something, that is the answer to a division problem. If we have 0.9 over 3, that is a fraction, which is dividing. If we have 460 times 12, that's not dividing because it has a multiplication symbol. If we are putting something into groups, we are dividing whatever that is into the different groups. If we have 181 divided by 9 with our little box, that's division. And then if we have 4 times 8 over 9, that is multiplication. That little dot there is a multiplication symbol. All right, so now we're going to label the parts of each division problem below. So as you can see, we have 3 different types of division problems. So in our first example, if we have 30 on the outside of our box, that is our divisor. If we have 510 inside our box, that is our dividend. And then 17 on top is our quotient, our answer. Now, if we have 312 over 12, the top number is going to be our dividend. And our bottom number is going to be our divisor. So the bottom number is what would go on the outside, and the dividend is what would go on the inside. And then we have 437 divided by 19, so we're using our division symbol. 437 would be our dividend, and 19 would be our divisor. So if we were to write this using our little box, 19 would go on the outside, and 437 would go on the inside. All right, so now let's practice solving the questions here. And we have some boxes here just to help us practice with our lining up. So I'm going to simply transfer our question. So I'm putting 27 on the outside and 1,134 on the inside. So we're going to start by saying 27 can go into 1. Well, 27 can't go into 1, so I'm going to put a 0 there. Then we say 27 can go into 11. Nope, it can't, so that's a 0. Can 27 go into 113? Yes, it can. It can go in 4 times, and then 4 times 27, which is 108. And now we are going to subtract. So first we have 3 minus 8, which we can't do, so we're going to borrow from the 1, which becomes 0, and then our 3 becomes 13. And 13 minus 8 is 5. 0 minus 0 is 0. 1 minus 1 is 0. Now we're going to go ahead and bring down that 4. So now we're going to ask ourselves, how many times can 27 go into 54? And it can go in twice. And 27 times 2 is 54. We subtract 4 minus 4 is 0. 5 minus 5 is 0. So we are left with 0. So we know our answer is done for this problem. There's no remainder because we were able to get to 0. So our answer is 42. Now we have a problem, 3,672 over 18. So this one is written as a fraction. So I'm going to put 18 on the outside and 3,672 on the inside. So I'm going to start by thinking, how many times can 18 go into 3? It can't, so that's a 0. How many times can 18 go into 36? Well, that would be twice. And 2 times 18 is 36. I'm going to subtract. 6 minus 6 is 0. 3 minus 3 is 0. Now I bring down the 7. Can 18 go into 7? No, it cannot. So we're going to put a 0 up there. 0 times 18 is 0. We subtract. 7 minus 0 is 7. Bring down the 2. And now we're going to see how many times 18 can go into 72, which is 4 times. So 4 times 18 is 72. I'm going to subtract. 2 minus 2 is 0. 7 minus 7 is 0. And we know we're done because we were able to get to 0. So again, no remainders. We got to 0. So our answer is 204. All right, this time we have 5,224 divided by 8. So I need to rewrite it using our little box. So 8 is going to go on the outside. 5,224 is going to go in the inside. So I'm going to start by saying 8 can go into 5. It can't. That's 0. So now I'm going to see how many times 8 can go into 52, which is 6. 6 times 8 is 48. Now I'm going to subtract. So we start with 2 minus 8, which we can't do, so we need to borrow from the 5. That becomes a 4, and the 2 becomes a 12. 12 minus 8 is 4. 4 minus 4 is 0. And I'm going to go ahead and bring down that 2, which is 42. So how many times can 8 go into 42? That is 5. 5 times 8 is 40. I'm going to go ahead and subtract. 2 minus 0 is 2. 4 minus 4 is 0. And I'm going to bring down that 4. So now we have 24. 8 can go into 24 3 times. 3 times 8 is 24. Subtract. 4 minus 4 is 0. 2 minus 2 is 0. So once again, there's no remainders. We were able to get to 0. So our answer is 653. Each of the cards on the left has the same solution as one of the cards on the right. Find the matching expressions to complete the sentences below. So we're going to do these in order. So we are going to start with A, which is 735 divided by 21. So 21 goes on the outside. 735 goes on the inside. 21 cannot go into 7, so I'm going to put a 0. 21 can go into 73 3 times. 3 times 21 is 63, so I'm going to go ahead and subtract. 3 minus 3 is 0. 7 minus 6 is 1. I'm going to go ahead and bring down that 5. So now we have 105. So how many times can 21 go into 105? That is 5 times. And 5 times 21 is 105. Subtract. 105 minus 105 is 0. So card A has a solution of 35. Now moving on to card B, we have 496 divided by 31. I'm going to put 31 on the outside and 496 on the inside. We start by saying 31 can go into 4. It can't, so that's 0. 31 can go into 49 one time. 1 times 31 is 1. Subtract. 9 minus 1 is 8. 4 minus 3 is 1. Bring down the 6. We have 186. 31 can go into 186 6 times. 6 times 31 is 186. Subtract. We get 0. So card B has an answer of 16. Card C, we have 638 divided by 22. I'm going to put 22 on the outside and 638 on the inside. 22 cannot go into 6, so I'm going to put a 0. 22 can go into 63 twice. 2 times 22 is 44. Now I'm going to subtract. We have 3 minus 4, which I can't do, so we're going to borrow from the 6. That becomes a 5. The 3 becomes a 13. 13 minus 4 is 9. 5 minus 4 is 1. Bring down my 8. We have 198. 22 can go into 198 9 times. 9 times 22 is 198. Subtract, and we get 0. So the answer to card C is 29. Card D, we have 2,691 divided by 23. I'm going to put 23 on the outside, 2,691 on the inside. 23 cannot go into 2, so I'm going to put a 0. 23 can go into 26 one time. 1 times 23 is 23. Subtract, 6 minus 3 is 3. 2 minus 2 is 0. Bring down the 9. 23 can go into 39 one time. 1 times 23 is 23, and I'm going to subtract. 9 minus 3 is 6. 3 minus 2 is 1, and I'm going to bring down my 1, so we have 161. 23 can go into 161 7 times, and 7 times 23 is 161. Subtract, we get 0. So our answer to card D is 117. All right, moving on to card F. So now we're going to be doing the cards that match one of the 4 answers we had previously. So for card F, we have 1,344 divided by 84. I'm going to put 84 on the outside and 1,344 on the inside. 84 cannot go into 1, so I'm going to put a 0. 84 can also not go into 13, so I'm going to put a 0. 84 can go into 134, and it can go in once. 1 times 84 is 84. We're going to subtract. 4 minus 4 is 0. 3 minus 8 we can't do, so I'm going to borrow from the 1. That becomes a 0. The 3 becomes 13. 13 minus 8 is 5. And then I'm going to bring down that 4 so that we have 504. 84 can go into 504 6 times. 6 times 84 is 504. Subtract, we get 0. So card F matches card B's answer, which was also 16. So card B and card F have a solution of 16. All right, card G. We have 261 divided by 9. Put 9 on the outside, 261 on the inside. 9 cannot go into 2, so I'm going to put a 0. 9 can go into 26 2 times. 2 times 9 is 18. I'm going to go ahead and subtract. 6 minus 8 we can't do, so I need to borrow from the 2. That becomes a 1. The 6 becomes a 16. 16 minus 8 is 8. 1 minus 1 is 0. Bring down the 1, so we have 81. 9 can go into 81 9 times. 9 times 9 is 81. Subtract, we get 0. So card G has an answer of 29, which matches card C. So card C and card G have a solution of 29. Card H. We have 595 divided by 17. We go ahead and put 17 on the outside and put 595 on the inside. 17 cannot go into 5, so I'm going to put a 0. 17 can go into 59 3 times. 3 times 17 is 51. I'm going to go ahead and subtract. 9 minus 1 is 8. 5 minus 5 is 0. Bring down that 5. We have 85. 17 can go into 85 5 times. 5 times 17 is 85. Subtract, and we get 0. So card H has an answer of 35, which matches card A. So card A and card H have a solution of 35. All right, last card. Card I. We have 1,404 divided by 12. 12 goes on the outside. 1,404 goes on the inside. 12 can't go into 1, so I'm going to put a 0. 12 can go into 14 one time. 1 times 12 is 12. I'm going to go ahead and subtract. 4 minus 2 is 2. 1 minus 1 is 0. Bring down that 0. We have 20. 12 can go into 20 one time. 1 times 12 is 12. And I'm going to go ahead and subtract. So we have 0 minus 2, which we can't do. So we need to borrow from the 2. So our 2 becomes a 1, and our 0 becomes a 10. 10 minus 2 is 8. 1 minus 1 is 0. Bring down that 4. We have 84. 12 can go into 84 7 times. 7 times 12 is 84. Subtract, and we get 0. So card I has an answer of 117, which matches card D. So card D and card I have a solution of 117. In preparation for open house, the campus secretary copied handouts in sets of 25. If she made 1,675 copies, then how many sets did she copy? So when we are reading story problems, we're first going to figure out what our question is. What is it asking us to do? Well, it wants to know how many sets did she copy. So I went ahead and underlined that. You can underline it, circle it, or highlight it. Whichever one you want to do is completely fine. So now that we know our question, we need to look in our problem to see what numbers we have that we need to use. So we know the campus secretary copied handouts in sets of 25, so I'm going to go ahead and circle that. And she made 1,675 copies. So those are the two numbers we are going to be using. So what do we know? We know that she made sets of 25 and that she made 1,675 total copies. So what do we need to know? We need to know how many total sets they made. So now I'm going to go ahead and solve this problem. So I'm going to put 25 on the outside and 1,675 on the inside. So 25 cannot go into 1, so I'm going to put a 0. 25 cannot go into 16, so I'm going to put a 0. 25 can go into 167 6 times. 6 times 25 is 150, and now I'm going to go ahead and subtract. 7 minus 0 is 7. 6 minus 5 is 1. 1 minus 1 is 0. Now I can go ahead and bring down that 5, so we have 175. 25 can go into 175 7 times. 7 times 25 is 175. If we subtract, we get 0. So our question has been solved. She made 67 total copies. All right, last question. Mr. Jackson hires his neighbor, Timothy, to walk and feed his dog for the month of June. He tells Timothy that he will pay him $270. How much will Timothy make each day? So the first thing we're going to look for is our question. So we need to find out how much will Timothy make each day. And our numbers we know in the total month he's going to make 270, and it is the entire month of June. And for those of you who don't know, June actually has 30 days. So what do we know? He is going to be working for 30 days and he is going to be making a total of $270. So what do we need to know? We need to know how much he will make each day. So now I'm going to go ahead and solve our question. So I'm going to put 30 on the outside and 270 on the inside. 30 cannot go into 2, so I'm going to put a 0. 30 cannot go into 27, so I'm going to put a 0. 30 can go into 270 9 times, and 9 times 30 is 270. Go ahead and subtract, and we get 0. So this one was pretty simple, pretty quick. So how much will Timothy make each day? Timothy will make $9 per day. So now you can go ahead and take a minute to summarize what you learned in today's lesson.